In this video, we're going to work on taking our understanding of solving radicals just a bit deeper with some more complicated configurations with these equations. But before we get to more complicated configurations, let's start by looking at one that is like what we've already done. Alright, let's say we have the square root of 2x plus 3 minus 5 equal to 8. So we want to solve this guy. And our general strategy is to undo what's happening to x. So that means that first we're going to add 5 to both sides of the equation. Next we're ready to cancel out the square root, and we're going to do that by squaring both sides of the equation. So when we do that on the left, the square root and the square cancel each other out, leaving us with 2x plus 3. On the right, we just have a number, 13. 13 squared is 169. So then once we eliminate the radical piece here, what we're dealing with is a linear equation. So I just need to subtract 3 from both sides and then divide by 2. When I subtract 3 from both sides, I get that 2x equals to 166. And when I divide by 2, I get that x equals to 83. Now these were the equations where what we come up with down here may or may not be a solution to the original equation, because when we square a radical equation, we change the equation so that the new equation has all the same solutions but possibly more than what the original equation had. So these are the ones where no matter what we did, and if we did our math right, we still have to go back and check our solutions to see if they actually are solutions to the original equation. So we're basically checking to see if the square root of 2 times 83 plus 3 minus 5 equals to an 8. So does the square root of 166 plus 3 and then minus 5 equal to 8? Which brings us to the square root of 169 minus 5. Does that equal 8? Well, the square root of 169 is 13, so that gives us the question, does 13 minus 5 equal 8? And sure enough, it does. So we get 8 equals 8, which means we can declare 83 to be a solution to the original equation. So that's kind of what we've seen with the radical equations we've done so far. There were a few that were cube roots, in which case we had to cube both sides when we got ready to eliminate the radical. But that's the basic gist of what we've worked with so far. Now let's mix it up a little bit. Alright, so let's say we have the square root of 3x plus 3 and then plus 5 equal to x. So it's going to kind of be the same. What's going on differently with this equation is I have an x that is not under the radical. And so that's going to change how the problem plays out, as you'll see. But our process will be similar initially. What we want to do is subtract this 5 off to get that to be 0. So we're going to subtract 5 from both sides. So we get that the square root of 3x plus 3 equals x minus 5. So notice now we're getting two terms on the right, because those can't combine because they're not just a couple numbers now. So what we'll need to do now is eliminate the square root by squaring both sides. Once we do that, on the left the square roots will cancel out. The square root and the square will cancel out like usual, leaving us with just the 3x plus 3. Now on the right, it's a little bit more complicated. Again, I want to remind you, we cannot just distribute the squared to the individual terms. You cannot do this that way. You can't do that ever with a binomial squared. What we need to do is multiply the x minus 5 times the x minus 5 by distributing out the terms. That's going to give us an x squared minus a 5x minus another 5x and then plus a 25. Now that we have that distributed out, we can combine like terms in the middle there, and we get x squared minus 10x plus 25. Now what you're probably seeing or noticing is that by having this extra x outside of the radical in the beginning, when we multiply things out, we end up with a quadratic equation, or an equation with its highest power of x squared. And so the way we go about solving this is going to be more complicated. We need to use our quadratic equation solving techniques. Since I have an x term, I cannot, or actually I have a couple x terms, I cannot use the square root property. So what I need to do is get this equal to 0 and see if I can solve it by factoring. To get it equal to 0, I'm going to subtract 3x from both sides, and I'm going to subtract 3 from both sides. That gives me x squared minus 13x plus 22. And I'm going to move the equals 0 to the right because I like it better that way. So what I'm going to do, since I've run out of space here, is I'm going to carry this problem up here to the top. And since our a is a 1, what we're looking for here are factors of 22 that add to a negative 13. That's going to be a minus 11 and a minus 2. And then once we have it factored, we can set each factor equal to 0 and solve the mini equations. So for our first mini equation, I'm going to add 11 to both sides, and that gives me x equal to 11. For the second equation, I'm going to add 2 to both sides, and that gives me x equal to 2. So we're going to say that x equal to 11 or x equal to 2 are solutions to the equation, but that they may or may not be solutions to the equation. Again, this is a radical equation, so we have to go back and check those solutions in our original equation, and we have to check them each independently. It could be possible that 11 is a solution and 2 is not, or vice versa, or they could both not be solutions, or they could both be solutions. So we have to check them each independently. Alright, so what I'm going to do is clear out all the work we have. I'll leave the original equation and I'll copy over the solutions, and that'll give us room to show the check on the screen. Alright, so we have our equation and we have the x equal to 11 or x equal to 2. So I'm going to first check x equal to 11. So that means plug it into the original equation where there was an x. So I'm going to plug it in on the other side as well because there's x's on both sides. And I'm not saying they're equal, I'm asking if they are equal. So 3 times 11 is 33, plus 3 is 36. So we want to know if 36, the square root of 36 plus 5 is 11. Well, the square root of 36 is 6, plus 5 is 11. So sure enough, we have that 11 equals to 11. That works, which means x equal to 11 is a solution to the equation, or 11 is a solution to the equation. Now let's check that x equal to 2. So this time I'm wanting to see if the square root of 3 times 2 plus 3 plus 5 equals to a 2. Well, 3 times 2 is 6, plus 3 is 9. So that's asking if the square root of 9 plus 5, does that equal to a 2? Well, the square root of 9 is 3, so does 3 plus 5 equal to a 2? I don't think so. Sad face. So what that means is we have to ditch the x equals to 2, but 11 is still a solution to the equation. And there we have it. That's the process of solving through these. Again, you have to check each solution independently because one could be a solution, neither could be a solution, or they both could be a solution. So make sure you take the time to check both of them independently when you're doing the work. So go ahead and try to knock some of these out and see how you fare.